So perhaps one way to maybe introduce this is when we talk about highways having a junction, what does that possibly mean to you? For instance, when you get to the four-way stop in Madison, okay, that is by Pizza Ranch, and then so if you're coming from the south, Pizza Ranch is here. There's Highway 34, north is 81. There's a gas station across the way, and then the city park and pool is to the right. So what do you suppose that means by junction? It could be an intersection. In other words, the best way to look at that is when two come together. It would be both Highway 34 and Highway 81. That's called a junction, where those two highways merge. Did you say merge or come? Which was it? When they intersect, that can be a way of looking at that as well. So what do you suppose we mean by a neuromuscular junction? What would that mean to you? Yeah, where the neuron, it's not that it comes in contact with a muscle cell, because it just doesn't. Because at the terminal end of that axon is called this specific structure. I want to get inside of something, so it's on a door. It's got a specific name, though. Synaptic knob, okay? Because when we talk about a synapse, okay, remember, that neuron does not come in contact with that muscle cell. So there has to be a chemical signal sent between that gap, okay? So what is that signal that goes across? We drew it with triangles yesterday. Okay, not just a transmitter. You're so close. It's a neurotransmitter, okay? And then when that goes across, the specific name of that neurotransmitter starts with an A. Acetylcholine, yes. And one of the things that I would venture to believe that is a reoccurring thing throughout the animal kingdom, not just with humans, but with animals, especially. You could say bug spray. If it's a type of spray that, whether it's hornets, flies, hopefully not bees, because you don't want to kill any bees, but that spray that you put on them probably interferes with their synaptical cleft, you call it that, or that neuromuscular junction, because we're not the only ones that use neurotransmitters called acetylcholine. So if you had heard of a term acetylcholinesterase, what does that tell you? That is a what? A/N acetylcholinesterase. You're going to say, I knew that. Yeah, it's an enzyme, okay? So acetylcholinesterase is an enzyme that can break that binding site because it takes energy to do that. So then when a body, like we said yesterday, goes into rigor, is much easier to say. Is it rigor mortis? I don't know how you pronounce it. Okay, say that again really slow. So
Rigor mortis.
Rigor mortis. It's not mortis? Okay. Rigor mortis. Hey, I think I got it right. Okay. Go by what I mean, not by what I say. Have you ever heard that before? Rigor mortis. Why does a body go into that? Why are those muscles still contracting? Yeah, the acetylcholinesterase is not working because it needs energy for that enzyme to work. So if those those bonds cannot be broken, that's going to remain contracted. Eventually, like all enzymes possibly do, they just start to degenerate or degrade. Is that a better term? Yeah. Degrade and break down, and eventually those muscle cells just slowly release, okay? Because that's one of the things that happens when we talk about rigor mortis. I got it right that time. Okay. So moving forward then, so this synaptical cleft, or this synapse, is where the axon comes down to a muscle cell. So the process is called a synapse at the synaptical cleft, which means you have a synaptical knob that's stimulating a muscle cell with that of a neurotransmitter called acetylcholine. All right, so we move forward to more so of the central nervous system now. I just don't think there's a whole lot left, because I know it says 16 to 21, but it doesn't go all the way through 21 slides. I want to say there's only about 3 slides left after this one. Otherwise, I would have said go ahead and take over, but there's just not a lot left. Okay, one of the things that this is a very vital function, because what it's protecting the brain and spinal cord. So how do you suppose that goes through a protection? Because your brain is inside a cranial case of which bones from last spring? Frontal is 1. Occipital is 2. And how many parietal? Is there 1 or 2? There's 2 of those. So your cranium is made of those 4 main bones. There's actually 8 total, because you have a sphenoid and temporal? Temporal. There we go. Sphenoid and temporal bones. Okay? So that makes up that cranial case. And what type of joint would you envision your cranium is? Is there any type of movement there? There shouldn't be, okay? So that's the key. Have you ever heard of meningitis? You may have heard of it, but that doesn't explain. What do you suppose meningitis can mean? Okay, so you can back up to bronchitis, laryngitis. I'm trying to think of other types of, I want to say, injuries happen throughout the body, because most, okay, gastritis, there we go. That's probably a little more familiar. If you have gastritis, what might that be? Say that again. Can be, yes, yes. So maybe bronchitis is a little more familiar, because what would bronchitis mean to you? It is something with your lungs. So you're not wrong when you say fluid, okay? Is there an infection in your lungs? Yeah, infection that causes inflammation, and this inflammation is bad enough that you are creating not just fluids but mucus inside your lungs. So if it's gastritis, what might that be? Inflammation where? In your stomach, exactly. So now if we see meningitis, what would that mean to you by looking at this? Can be inflection. Can be infection or inflammation. Those two go hand in hand in the brain or spinal cord. But if you have this infection taking place around your brain, what are some possible problems with that? Because what did we talk about with your cranium, where you have your 2 parietals, your occipital, your frontal bone? What's true about your cranium? It doesn't move. So if it can't move, if there's inflammation, what's that fluid going to do? It's going to swell, and what's that going to do to the human brain? It's going to put pressure on there, okay? So this inflammation that can take place in your meninges, that is of course quite serious. And this can be fatal in certain cases because I think, is there specific classifications of meningitis? For some reason, type C sounds familiar. So I want to say, happened on the campus of Dakota Wesleyan, I think. A student had been diagnosed or came down with meningitis C, and I think he didn't make it. That it was a type of inflammation in his spinal column or in his brain that unfortunately he succumbed to that infection, and it was actually quite quick. So these things, they do happen, unfortunately. Usually we think of inflammation as something that your natural body's response, which it is, but sometimes it's unfortunate where these inflammations can occur. All right. So when we look at the layers of these meninges, there's actually three. As you can see, the dura mater being on the far outside. And when we visited SDSU last spring, you can actually take a flap of this arachnoid membrane. So by looking at what you see, okay, what is the arachnoid membrane? What does it say? It's probably not the best definition because the arachnoid membrane is what encapsulates your cerebral cortex, correct? Yeah. Am I interpreting that correctly? So is the dura mater as well. Okay. Which, of course, we're quite thankful that people donate themselves to science in this manner. I mean, one of the things would it be any different if an individual donated themselves to science and they're in their 40s? Because most of them that come through are probably, what, in their 80s, maybe? Of course, every human body is going to look like every other one, but I don't know. The skin would be different. I don't know the muscle texture. I don't know if that'd be any different either.
I think
it'd be bigger. Okay.
There's probably not as many diseases that you can see. We find a lot of like kidney cysts.
Okay.
Stuff like that. So there's some be less that sort of thing.
Ooh. Yes, and I just wonder whether it's a cyst or if it's I suppose that's related to a kidney stone, I would think. It might, a cyst might be an infection or a kidney stone is.
Infection, I believe.
Okay. But whether for men or women who have to pass a stone, that is going to be, of course, quite painful. And because of the human anatomy, who's going to go through, it's going to be painful for both, but who's going to go through more pain, men or women? Do you think? You got a 50-50 chance. Men do. I would be led to believe, but we're just wimps, okay? So when you say men, why would you say that it's more difficult or more painful for men than it is women? Because after leaving the kidney, okay, and then where do materials go after the kidney? Goes to this structure that starts with a U. Well, you say bladder? So urinary bladder, okay? So then, whether it's men or women, once it's inside of the bladder, where does it go for men and women after the bladder? That also starts with a U. I don't know if you remember that from health class. Have you had health class? So who has had it? And if you've had it, it doesn't mean that you've covered this. So after the bladder, this other tube that starts with a U. That would be a common name. Urethra? Is that? I think that's what we would refer to that as. So that still doesn't answer the question, why would it be more painful for men to pass that stone going through the urethra than it would for women? Sorry? Yes, it has to actually go further. That's right. So the urethra in men is going to be longer than it is for women. So guys, that's kind of unfortunate for us. But we're wimps anyway. That's why we don't go through childbirth. That's why the way the man upstairs designed us, that we lucked out on that one, guys. Yeah. Right? There's probably other things we could say that we lucked out on, unless you shave your legs. I don't shave my legs. Mr. Wagner, you shave your legs? I don't shave mine either. So that's another, there's other things we could talk about where we missed out and lucked out on that one. But with kidney stones, trying to pass those, again, that would be actually quite painful. All right. This one, and then, yeah, then we're about done. If I had the skeleton out here, we could possibly show you what that spinal tap would look like. So there's different reasons or different procedures that would be similar to a spinal tap. Okay? And who can we pick on in here? We don't want to pick on anybody? Let's go with the first name I hear. What was it? Well, yeah, well, it's his day because he's running from that bull in the story problem behind there. Sure, I guess we can do that. Yes, sir. Okay. So just like it says here, when it says tap, it means you're removing fluid, and it's coming out of the spinal cavity. Okay? So the potential problem with that is from the surface of the skin to in between the vertebral column, what type of length do you think you're looking at? Is it just a needle about like 1.25 inches, 2.5 inches, 3 inches, 4 inches, 7 inches? Okay, I would say, what's that, maybe about 8? Okay, so picture a needle. Well, that's why I got this pencil here. So if this is where the skin starts, okay, I'm concerned about Mr. Wagner. Okay, lay down on that table. Okay, no, you don't have to do that, but if you did, okay, here's the surface of the skin. Just picture, okay, here's that needle going down past through the skin. And look how far that has gone. I mean, you look at a pencil, it doesn't, wow, that's not very long. But by the time you pass that through the skin, through the vertebral column, and into the spinal column to withdraw that fluid, you're looking at a needle that's not only quite long, but what else maybe? Quite big too, okay? So, do you need a spinal tap? Okay, I just didn't know if you wanted to volunteer, because I would do the procedure. Yeah, I would. Because I can't handle pain. I can inflict it, but I just can't handle pain. Yeah, maybe I could. I don't know. But I had seen this in a couple times as a rerun on Chicago Fire. Does anyone watch that show a lot? Okay. And I'm just going to guess, this is from last year's seniors, okay, their favorite character was Kelly. Is that your favorite character? I know, he was mine too. I like Herman too, but Casey's gone. But it's not Kelly, Severide, whatever. He's not your favorite character? That's what they said. Okay? Have you seen all the episodes? Because he donates some of his, not spinal fluid, bone marrow. Did you ever see an episode where he donates bone marrow to a patient? You maybe have. It just doesn't ring a bell. The problem with that is, this is the show going through. We can't give you anesthesia for this. We got to be able to harvest that without any anesthetics. So there's this needle going in down through his back to extract this bone marrow without any painkillers or anything. But that's why I think that's just not going to happen, I don't think. Although, if it's important enough, maybe you could mentally shut that pain off. I don't know. I don't want to find out. There are some tough guys. I don't think I'm one of them. But anyway, I'm not speaking for all men, but I'm just saying we're wimps. But that's what I'll just talk about myself. Anyway, so there's another diagnostic tool that resembles a spinal tap that would be unique to women, and you probably have heard of it, but just you haven't had to think about it because it has not applied to you should you make this choice.
The epidural.
What is an epidural?
It's a medicine that you get when you're going into labor.
You joining a union? Going into labor? Isn't that what labor unions are?
Oh, no.
No. Oh, okay. Oh, childbirth. Oh, okay. Yeah. Yeah. Because sometimes we talk about labor, we're talking about unions. No. Okay. But it would be the same type of procedure, but I would be led to believe if I was a woman and I had to give childbirth, I'm getting the epidural. I don't care how much, because when you compare the pain for that, I don't know. But we lucked out on that one, guys. Okay. But I do believe another diagnostic tool it's actually in the meninges. I think you can detect carbon monoxide levels. I don't know why I remember that, but I think you can detect that within the body. It's through the cerebral spinal fluid. Okay. We got this one, and then that would be it. So then, when you look at this here, that's kind of a misconception unless you really think about it. We'll explain that in just a moment. Is plexus or plexi an important term that they should know?
Yeah, I think it's pretty easy to explain flex.
What, 4 of them?
I got cervical, brachial, lumbar.
I can say it's probably 3. But for some reason, I had 4 in my mind. And that's something that we can discuss at a later time, okay? So when we look at this here, it says there are 31 segments that give rise to pairs of spinal nerves. Because when we look at the spinal column, okay, Why are we not saying 24, do you think? Because there's 7 cervical, okay? Then there's 12 thoracic, then there's 5 lumbar, okay? So 5 and 7 gives you 12, your other 12 from your other thoracic vertebrae. Why does it not say 24? Why does it say 31, do you think? Because what is below your lumbar vertebrae? It's still part of the vertebral column. Not only do you have the tailbone, but above the tailbone, but below the lumbar vertebrae. Starts with an S. And it's probably something we learned last spring. SAC, SAC something. R, sacrum. Ah, sacrum. There we go. Because there's also branches in the sacrum as well. And that probably gives rise to one of those plexi as well. Okay. So now, if we did not see these terms here, if it was the first time that you saw ascending and descending tracks, okay, how would you, just because it says ascending, which is true, does that mean it's going to the brain or away from it? It's going to the brain. So not only is it the ascending tracks, is that the afferent or efferent division? When it's going up, okay, is that afferent or efferent? So it's the afferent tract, because one of the things we talked about when we refer to English and grammar, you have cause and effect. So if this is the cause, okay, pain signals going to the ascending tracts through the afferent division, an outgoing response is going to go through the descending tracts or efferent division. So the efferent is the effect then. And do you suppose, is it possible to, let's say, shut down those skeletal responses? Besides yourself and yourself for sure, and maybe yourself, what do you three have in common? Okay? Besides you three, is there someone in here who's wearing contacts right now besides myself? Okay? So if you don't wear contacts, can you take your finger and touch your eyeball?
Yeah.
You can do it. Well, of course you can, but you can do it too? What about anybody else? You're shaking your head no, and I believe that. Why is that? Not only have you never tried, there's probably never been any reason to. One of the things that happens is through the course of doing that, how many of you can put your contact lens in? Do you wear contacts? Okay. Of course you do, and you do. Can you put contacts in with just 2 fingers? Okay. How about with just 1 hand then? Okay. One of the things, you just do this and just pop it right in. It's like that. Okay. Well, put the plunger down on the sink. Okay. Last thing we want to do is all of a sudden it drops down and then goes down into the drain. Well, I was going to try that. That's what we talked about in A&P. Oops, sorry, Mom. I washed my contact down the drain.
I just use daily contacts. So I can
Oh, okay. Yeah, I suppose that works too. Okay, so I think that does it for this chapter. So these ascending, one of the other things I was thinking about is I don't know, probably not anymore, but it used to be I could pick things up that were hot that just did not bother me for a long time back in 2015 and 2016. And then now I'm starting to get all the feeling back in my fingers because working on metal containers in a really hot environment, everything's hot, no matter what you touch. When your daily highs are somewhere around 110 to 120 degrees, every day it is hot. And you're working on something metal, it's going to be hot. So eventually, this really doesn't bother me anymore because it's so hot. So you can slowly, let's say, your brain will compensate for that, and maybe where the normal person can't hold on to something hot, you can actually just shut that off. I'm not saying it's very smart, but it is possible. Okay, that's all I have. We have some papers that will be handed out that we see right now. We're looking at a week from tomorrow. Okay, so coming up, we also have your vocabulary evaluation on Thursday. So I didn't know where we're sitting. Obviously, we got the chapter wrapped up, so we can go ahead and work on these tomorrow. And so we'll catch up to you next time.